I'd like us to look at one more rule on predicate logic. Um, it's called quantifier negation. Quantifier negation is an interesting rule. The interesting nature of that rule is if you change the negation, the quantifier changes. If you shift the negation to one side of the quantifier changes. So for example, quantifier negation is an equivalence rule, by the way, so it can be done on a part of a line. And when you do quantifier negation, it looks something like this. Assume that you have a statement like this. That statement, when you apply quantifier negation, step 1, step 2, quantifier negation will bring the tilde between it and the predicate letter and its subject. But as soon as that happens, the quantifier changes. So you can say one quantifier negation. If you had something like this at step 1, and then you did quantifier negation, so that now instead of what you have here, this is what you have, then the backward looking E drops. It's that simple. It is that simple. Actually, you have two more instances. Let's assume that you had something like this. And you brought the quantifier negation over here, and the quantifier over here, so that you ended up with that. That's what you will have. Okay, and then of course when you do double negation, then you say, sorry, this is one quantifier negation. This is one quantifier negation. Then you have that. Then you have two double negation. That's how you arrive at it. It's a very convenient rule, very convenient in predicate logic. And so when you're applying it, or when you're trying to do proofs in predicate logic and you end up getting stuck, try quantifier negation. In fact, quantifier negation can prove very useful for reductio ad absurdum, because with reductio ad absurdum you assume the negation of the conclusion and then you change the quantifier. Okay, so try and employ that and see how it works. If, for example, you look at this, by the way, I'm looking at section 9.4. Should have told you that right from the beginning. For example, exercise 9.4, construct proofs to show that the following arguments are valid. That is page 469. You may use direct proof, CP, or RAA. Look at question 1. Let's see how that applies. Question 1. Quantifier negation on question 1. We will use RAA. So you have for all x, AX arrow. Oh, that x binds only that. And then for all x, BX. And then from this 2, not x, dx. Then the conclusion I can use direct proof for this, or I can use quantify negation. Not quantify negation, but RAA. Let me just use direct proof and see how I can go. Notice that since this is a direct negation of that, you can do modus tollens with it. You can. And this is what you're left with. Not x, kx. So you say 1, 2, modus tollens. And then simply do quantify negation there. And that's what you have. 3, quantify negation. That's exactly what you're looking for. So again, it's not as difficult as people think it is, or some people think it is, or some students tend to think it is. It's fairly easy. Having given you that exercise, try questions, that is part A, 9.4 part A. You'll find that on page 469. Try doing questions 2, 3, 4, 5, 6, 7, 8, 9, and 10. And see how far you can go with that. Okay. I would love to take you through the logic of relations, but I really think we need now to get down to meta-logic. Once you have worked on everything, let me get the book. Here it is. I suggest, as you do meta-logic, as you read, don't worry about reading the preface. You can read it if you're interested. But this book, I hope I'm holding it right. There you go. Read page 3, and then read page 4 and 5. Look at the exercises and the answers to the exercises. And then next week, I will make a presentation for you on just that very section, formal languages. And then we'll just move on to interpretations of formal languages, model theory, and so on. Okay? So be prepared for that, because we need to really get into this. Thank you. See you next week. Blessings.